Okay, piecewise functions 1.3. We're gonna take a look at how to put these things together. You have a sheet that kind of looks like this, and they've got this first example on there. And before we talk about putting the pieces onto the graph, something I really like to do is how do you graph y equals -1? Because what this is this is three different pieces. That's why it's piecewise functions. And the first one is y equals -1. So if I go over to this graph and graph f of x equals -1, I have a horizontal line where it's -1 all the way across. Let's assume I did a good job with that, which is not that safe of an assumption. Okay, and then I'm going to graph the next one is 1 plus x, or x plus 1. So I would have a y-intercept of 1, a slope of 1, and I'm graphing, and it's going well. And how do I graph y equals x plus 1? Like, this is Alg 1 material, right? And there's the second one. And then lastly, I want to graph 2x, which looks like this, goes through the origin, has a slope of 2, up to right 1, and it looks something like this. Okay? So graphing all three of these, this is y equals 2x, this one was y equals x plus 1. Graphing all of those separately really isn't that big of a deal. And even when you take it out a step further, if you take a look at the three pieces, what they're looking for here is, oh, and this isn't going to work, is it? Because it's going to erase the whole thing. Oh, it does. Oh, well. Now, what they're looking for here is they're only looking for y equals 1, and we're only looking for it from where the x values are less than or equal to 3. So I kind of like to go here and go, well, here's x is 3, and I'm just going from this point backwards. So that's the only piece of that graph that I want, okay? And you can see that one right down here. There's the piece. All right, so now I'm going to go and I'm just going to graph. We'll take these two off of there. And I got some of those off of there. And then we're only going to graph that x plus 1, but I'm only going to graph it where I'm from -2 to 2. So you kind of go in here -2. So I can see kind of where I was there, that boundary point, but that's going to be an open circle, if I can make it open. And I'm going to connect up all the way to 2, which is going to be right up here. And I'm only going to graph that little bit right there, okay? And you can see that open circle up to there. Open circle up to there. And then the last one, I'm just going to graph the 2x, and I'm just going to graph it from where x is greater than 4. Well, how do I know where to go? Oh, well, wait, just put a 4 in there. 2 times 4 is 8. So I go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going where the x values are bigger than that, and I'm going to open circle. And now I just apply a slope of 2, and I go up through there forever. And that's this one up here. So what I always like to remind students is, you all know how to graph this one on its own. You all know how to graph this one on its own. You all know how to graph this one on its own. But now we're taking little snippets of it, or little, wait for it, pieces. We're taking little pieces and putting them together, okay? So when I go over to an example like this, I like to find my boundary points. Now you can do it however you want to do it, but I kind of like to go let's go. This is y equals 1. Well, that's a horizontal line. Where is it occurring? From where x is -2 and backwards. So I'm going to be, and I'm filled in because it's or equal to, but I want the graph to line y equals 1 from here backwards. Okay? So that's the red one. And then we grab a different color. Let's go green. Y equals x plus 2. Now, this one goes through the origin, but sometimes it's a good idea. You can just get the boundary points by plugging in. That's what plugging in will do for you. So my leftmost point will be -2, 0. -2, 0, open circle. And then I'm going to go all the way to put an x of 3 in there, and then y is 5. So I'm going to go 1, 2, 3, 1, 2, 3, 4, 5, and it's a closed circle, and I connect the dots. Now, this had a slope of 1, and it had a y-intercept of 2. Does the slope look like it's 1? Does the y-intercept? Yes, it does. But you're not always going to catch your y-intercept in there, and that's why plugging in and finding those boundary points is a really good idea. And then the last one, yeah, it has a y-intercept of 0 and a slope of 2, but something we can do here, I'll do blue, I can plug this in and figure out, well, where am I going to start? Plug that in, and I get 3 times 2 is 6. So I'm going to start at when x is 3, y is 6. That was 5, so it's one more. Well, this one doesn't even fit. Open circle, slope of 2. So that's going to go up to right one. It's going to go up quickly. Okay? And there's my 3 pieces. I just want the horizontal line y equals 1 going from -2 backwards. I have y equals x plus 2, and that's going from where the x is -2 open circle to where x is 3 closed circle. And then I have the graph of y equals 2x, and I'm going from where x is 3 open circle, and I'm going to the right because that's where the x's get bigger. So we really have our 3 pieces. Well done. Okay, take out the worksheet, the kind of homework worksheet that goes with it. I'm going to take a look at these 2. Now, this kind of goes back to your 12 basic functions, and there's a couple other things I want to answer while we're here. So we take a look at the first one, y equals -2x plus 3, and I'm doing it from where x is less than 1. So what I'm going to do is I'm going to substitute this in and get the boundary point. Put the 1 in there, and then I'm going to get -2 plus 3 is 1. So 1, 1 is my boundary point, and it's open. So I go to 1, 1, open circle. I'm going less than 1, so I'm going to apply a slope of -2. Negative slope's going to go like this, up 2, right 1, up 2, right 1, up 2, left 1. And now we graph that piece. Now I can do the next color, and I can do my red, and I'm going to plug in a boundary point again, and I'm going to do 3 minus 2 is 1. Oh my goodness, the boundary point for that one is also 1, 1, but it's filled in. What if you don't have 2 different colors? It doesn't matter, okay? If you can't tell, this one is filled in, it doesn't matter. It's a shared point. So this piecewise function, remember, these are functions, so they pass the vertical line test. So even though that one was open and that fills in, that's no problem, okay? And now I'm going to go to the right, and I'm going to apply a slope of 3, up 3, right 1, up 3, right 1. And it looks kind of like a V, but this one's going to go a little taller because of that 3, okay? These 2, the reason I want to do number 7 is those 2 are both from your 12 basic functions, okay? So we should know that 1 over x, if I remember back to 1 over x, it looks like this with an asymptote, and it looks like this with an asymptote because thou shalt not divide by 0. Well, they want when x is less than 0. Well, that's just that quadrant. So I can go over here, and remember a great way to graph this one is to put -1 in there, and then we turn the corner and we have an asymptote. So that takes care of that one. And then I go and I can get the square root of x, well, that's from greater than or equal to 0. Well, if you think about it, that's the entire graph for the square root of x, because it starts at the origin and it bellies out there. And I go 0, 0, and then I would go 4, 2, and 9, 3, and it would go like that. Okay, so boundary points is a great way to start them, and then apply the slopes. Remember your 12 basic functions, and work on the rest of that worksheet.